Hi, Matthias. Good to see you. Um,
Hi, Pavel. Good to see you.
Welcome, everybody, to the AI Weekly podcast, where we summarize the news of the week in artificial intelligence. Today, it's the 5th of August, and it's been truly an exciting week in AI. I'm especially interested in your take and your opinion on the new Parti model by Google Research and how these text to image models will impact the ecosystem around us.
Yeah, it's a truly exciting time, and we can see things moving forward very, very fast with more and more rapid release cycles, so to say. But it's kind of like it have been forecasting and been able to see over the last couple of years that the time between release of papers are drastically decreasing. So instead of waiting years or months on progression within an area, we can now, in some cases, see new, better approaches and versions be released just weeks between them.
Yeah, I mean, that is actually very exciting, and I think it's a common theme around the acceleration of innovation in artificial intelligence, because just this week, DeepMind, right, effectively announced that they have managed to predict the structures of nearly all known proteins, right? So just to give you, the raw numbers, they claim that they predicted almost 200 million different molecules. So this is every known protein, right? So if we remember, it was just a few years ago, I think it was less than 24 months that AlphaFold was announced, yeah, with the model of protein prediction or somewhere around that. And now we went into this tremendous acceleration curve where they can predict and kind of anticipate almost every known protein to humankind. And I'm wondering, where does that acceleration actually come from? Like, is it the computing, just raw computing power, or is it more information being just aggregated? Like, how do we get this tremendous acceleration? Why is it happening this way?
I guess it's basically because one big factor is that as we are implementing AI or other types of semi-automatic to automatic methods in different fields, it speeds up that part of the progress, which automatically kind of applies. I often use the term pro-acceleration, which means the acceleration of acceleration. Because if we imagine that we are on a more or less consistent progression, then as we manage to rapidly increase the speed in one segment, it means that the cycle becomes faster. And that means the reach to solve the next problem, or how to say the time to solve the next problem becomes shorter and shorter and shorter and shorter. So things should just keep accelerating, because to be honest, computers have never been close to automated. How much of the computing power are we using on a daily basis? Are we utilizing computers to 100%, or what is your opinion?
I think we're definitely not using them to their full potential. I think, even as a good example, the iPhone or any other phone and the image quality upscaling right around it. And that is like, you take an image from raw data, and right now you have systems that upscale the resolution, take multiple photos, allow you to frame it from different sides. Now, does it mean that this is the full power of that device, right? No, it's just like the technology from 2 years ago, especially in AI technologies, that is now coming to the day-to-day usage, right? But we could have much more advanced systems already on the phone. Like the phone can potentially could generate a video out of it or a 3D rendered scene out of it, right? Because the AI is progressing so quickly, and I don't think we are getting the real most advanced technologies to our computers and to our devices, especially like normal people. I'm not talking about like some of the people in our community, they get like super advanced tools and maybe they use their computers to their full potential. But most people, or they just use it, they don't even notice the artificial intelligence inside because it's not really the kind of state-of-the-art stuff, right? It's stuff that was tested and introduced, for months ago.
Yeah, it could very well be the case. I mean, the effort of training a model is extremely computing heavy. But once that is done, the amount of computing needed to actually run it is a totally different story and a lot less. And so there is always like with training and so the model, okay, it can often be a big hump, especially initially in a technology, because on one side also often what you see in AI is you kind of stacking progression upon each other. So once something is solved and trained, this data and this technology will often be used in the next paper, but you add something, you improve something. But once a process, and especially in the scientific area, I would say it's so impactful because things that would take 1 year to solve can now be solved in 10 minutes with technology. So that means that every type of other type of R&D or scientific work that includes this type of workflow are now heavily speeded up, so to say. So that means whatever type of thing they're trying to solve, they will reach there faster because of previous technologies that actually now have increased the speed for them. So I think I mentioned maybe last time we had this podcast, but I took an example about Google designing AI chips, which was taking them a very long time. I don't remember the specifics, but say it was taking towards a half a year to 1 year to actually make a processor chip design, or if it was it was for processors. Mm-hmm. But now with the help of AI, they can prototype and test this in like days instead of months. So that means we will be able to develop new processors faster. These new processors will allow us to train AI models faster. So it's a stacking acceleration, and we are probably just seeing the beginning of this. People often tend to talk about things stagnating, but I think we are extremely far away from that. And I think also that's due to the fact that previously in AI we were very focused on solving some specific tasks or reaching a certain goal. So we were looking at that all the time. But today, a lot of people are building AI solutions for almost every field in computing. So for each of these blocks that gets solved and get on place, it kind of accelerate the whole compute space, so to say.
Yeah, I mean, and I think that's why I say it's an exciting week, because like we've seen these upscaling of photos papers pop up over the last months, yeah? But now we have Tencent publishing a completely new model that is basing on this, right? And that allows you to effectively fix low resolution photos. And for AI to fill the gaps and create a high resolution photo. So we're talking about a bad picture of a dog or a person or an object, and the system can figure out what is the actual object and draw the gaps in the low resolution. So this is not possible over the last 3 months. This is months of work now being compressed into a use case that's feasible. And I think I see a lot of this happen with image. I also see a lot of this happening with sound, right? So everything that we see from big corporations, like Google or Microsoft, and the quality of the conversations, over our phones and over video chats, there's heavy AI algorithms that fill out these gaps in sound, right? So it's constantly sharpening the resolution of the sound, and it's sharpening the resolution of the image. And this has become so common that we treat it as standard, but it's kind of completely new way of designing software in this case, because rather than to create a perfect compression algorithm and a perfect, perfect channel of transfer of voice, you just apply an AI system that does this job much easier and much more effectively, right? And this applies to everything right now.
Yeah, I mean, AI have been used recently to actually figure out better compression methods. But what AI fundamentally means is actually trying all the possible ways to solve something and be able to do that in such a way that we can go through immense quantities of ways to solve a problem. And I think also one thing that also contribute to this much more rapid release, or one thing that also contribute to moving things forward, is also that we understand with each of these new papers and so on, what data is actually relevant, what data matters, what layers matters, because bottom line, training an AI model is about shuffling all this data around. So it's the combination of variables. So for every layer of variables we can exclude, could massively improve the training time and in the end performance. Because what is a computer bottom line? Like, how does it work? What does a processor do? It's like a small flashlights that goes on and off, kind of, but a lot of them. So the less data we need to run through it, or the more precise we can be around the data that really matters, the better it is, because just like one extra layer of variables could like explode this amount of possibilities with giganormous factors.
Yeah, and I mean, I think what I really like is that these models, these papers are public knowledge, right? So I really like that. And even, like you have companies that have always been very open about their models, but then you have companies, like Meta. And, this week Meta has open sourced their system, their model Theseus, right? So it allows or supports constructing, various problems in robotics and vision, right? And I think a lot of these innovations are connected again to vision, sound, automation, right? And like you said, constantly new knowledge is being added. And I think I'm just wondering, why do these companies make some of the libraries public versus make some of the libraries, and some of the models completely private? Like we see systems that are completely closed, versus completely public. And I understand that maybe they think that there's, more profit in the closed, like the ones that they can control. But why have the papers are open, the knowledge is there, everybody can benefit, yeah? So what's driving kind of creating an open source model for Google or Meta, for example, versus a closed model? What do you think? Like, have you ever considered this?
Yeah, absolutely. I mean, around a lot of the papers is that, very much like a scientific and research level where people want to share what they achieved. But in many cases, also people might share the papers and the outline and the insight from it, but in most cases they do not share the model they trained, which just because you have access to a paper doesn't mean you have either the knowledge or the capabilities to actually train this model, because there also it's a big you need access to the right resources, the right computing, and so on. So what we in many cases can see is that we have the release of the paper, we have release of the results, and then you can get partly trained model that you can access, but in many cases you can actually not access the top performing models, the one with the most capabilities. I'm actually looking at a recently article that came out yesterday that going through the top trends in artificial intelligence this year. So we can see at the number one is the NLP, so natural language generation. And I think most people would agree that this is probably one of the hottest trends right now.
Yeah.
What do you think?
I think that it's definitely the one that will get the soonest on the adoption curve. Yeah. And we were just discussing even today the usability, of adoption cycle from Gartner, and some people, think that it's not very useful to look at adoption from this perspective. I, on the other side, think like you said, NLP models, although for a very small percentage of people right now, I believe in the global population. I'm not talking about the developer community. I'm talking like 7.5, 7.6 billion people. Yeah. And they will get to use NLP models in their day-to-day life. Whenever they spoke to a human over a digital form of communication, this will very soon be subject, at least in the first layer, second layer of communication, with a natural language processing app service of whatever kind. Yeah. So this is something that will happen very quickly in the next few months. No question about this. I think that certain things reach a maturity, they get adopted, and then they get adopted very quickly. Like one person starts to use something, and then the whole industry switches. Yeah, it's like an introduction of a jet engine. Like, why would you fly on a propeller, plane, or why would you go on a glider or by horse if you can put a jet engine and just go full speed? So I think natural language processing models are one of the first technologies that will get kind of adoption on a multi-billion people using it.
Yeah, I think it's definite. What I believe is that it's the next generation of operating system, and actually how we control these operating systems. I mean, we do not. After we got the phone, we didn't write so many letters, right? Because with the phone we could communicate a lot faster. And generally, what I always seen like through time, and what seems to be a very red thread in almost every area, is that if something increase speed, so basically the bandwidth or the speed of sending data, it greatly it will always become the winner in the segment. So if we easily can control our computers, our applications, and so on with the voice, and just things will happen instead of us doing very specific processes to make it happen. It will change everything, and all our devices today are already compatible with this. And NLP and understanding of meaning. What do we mean when we say something? What does that connect to? Are really getting to the point. So I'm not sure in 5 years if it is Windows, if it is Mac OS, that are the default operating systems. Somebody could come and swoop in, and all devices on the market are already compatible with this. So if somebody comes in with something drastically different that have this new approach, they don't need to wait for, say, a hardware adaptation, because we have the screens, we have the microphone, we have the speaker, and this kind of what is needed. Then in many cases we have some keyboard and so attached, but yeah.
Well, that's
it will just
that's very bold, and I think we need to probably start a separate kind of discussion around just specifically this, like where is AI heading, not only this week but overall. I totally agree with you on the operating system, and I can see a company like Tesla that has tremendous AI capacity step in with an operating system that is completely different in the way that they operate, and deployed to millions of users instantly through infotainment systems. Even this week LG announced a new operating system, like LG, which you don't not normally associate, right, with a computer operating system. This week they announced that they will be bringing a voice-driven operating system for in-vehicle infotainment systems. Yeah. So this is a very good example of this. Is that in-car infotainment system completely driven by an AI NLP model. Yeah. So this is a very good example. Like, how is that operating system then different to your phone or your computer? Obviously, the device, and the environment in which you use it is different, but it's not a far stretch to think if I can use a natural language processing AI system to communicate with my vehicle, I can use it to communicate surely with my phone.
Yes, and it fundamentally changes, the whole user interference, because today everything is adapted towards us clicking using the keyboard. So all our UI are adapted around that. So how applications actually look and work will so drastically change also. So I believe almost everything we see today, it's going away, and it will happen very, very rapidly. And us as the users, we will not need to interact with so many of the layers between the front end of the application, because we don't need all the buttons. So I don't know what to compare it with, but let's just compare with some factory, and a couple of years back you had like these massive panels with like infinitive amount of buttons, but then the computer came, so now we actually could perform most of these tasks from this one little unit instead, and this is just the next step. what I find the most fascinating with this is actually that a big reason why this is happening right now is not necessarily because of AI progression. While AI and technologies around it are moving really, really fast. But the underlying reason to this right now is that we humans together have built this massive database. We have taken all our knowledge and we put it in this massive connected database called the internet. Are you with us, Pavel? Are you writing?
No, I'm listening. I'm making some notes for myself, but I'm just noting out the points that you are making. Yes, I think it looks like it's a stacking of conditions that correlate to the acceleration of innovation with the use of AI. So the availability of devices, the availability of computing and processing speed for local devices, and the computing power necessary to train models, then the constant aggregation of more and more knowledge. Yeah, one is the knowledge used to train models. The second is the knowledge that is published inside papers, right? And this means that one over the other is accelerating. Yeah, the availability of devices, the amount of users that AI can interact with, the number of feedback loops that are created. And it looks like we've entered, from what you're saying to me, from a purely economic point of view, is that you have these parameters, and each of these parameters only accelerates further. Yeah, so it's a stacking effect, and I think you used a nice word, like what did you say? Like a
Pro-acceleration.
Pro-acceleration. Yeah, I think that's we can coin.
It is a real term actually. It's the acceleration of acceleration. So it means that there is something that is accelerating, but we are consistently scaling that acceleration. So it's an acceleration is speeding up by default, but now we're adding a secondary acceleration on this. So the acceleration become unpredictable in such a way, because else we could more or less predict the curve of the acceleration.
And I don't think it's one. You said you were adding one condition. It's not one condition. So the amount of knowledge on the internet, the amount of papers being published, the amount of computing capacity to train models, and the amount of devices that can use models to interact with users and create feedback loops around that give you even more data. So it's multiple external components that are stacking on top of each other, and it becomes, as you said, highly unpredictable. So, and that's why I think we see, like, we've been doing the news for just a few weeks, but every week we see so much new stuff happening. Yeah, and I don't think there's any other industry that would have this amount of breakthrough components happen. Yeah, whether it's the car industry or it's the traditional computer industry or the biological, even the biotechnology industry or whichever other, will not have this amount of breakthroughs happen on a weekly basis. And I'm just I think this is what's popping out to me as a trend. And it's a very interesting week in that sense. So I mean, we could probably wrap up for this week and try to also maybe jump on another call, you and me, where we just discussed this pro-acceleration.
Yeah, because this is just the beginning of it. As soon as we have understood how to automate this stuff, the next step will become to how can we achieve the same thing. Like once we know how to automate the process from A to B, which we are kind of there, then we actually have the fundamental building blocks to now put AI to figure out how to actually perform, how can we perform the same task, but much more efficient from an AI perspective, because right now we are automating things that was written for humans by humans. And if we just look at such thing as, say, execution of data, so Python, whatever, compare that to such thing as C, for example. It's like we are talking many X difference in performance. But if the human element doesn't have to be involved there, what will the X in performance be then? So we are also there getting closer to something really, really exciting that overnight basically can blow up performance in computing to the stratosphere. But yeah, that's a discussion for another time.
Yeah, because my head literally
you.
exploded when you said this, because it opens up so many new possibilities, because then you add the component of AI just removing the human component out of this pro acceleration.
Yeah, because everything today are based that we have a
human
person like in this and building with it, so everything are adapted to this. So once we manage to automate, once we manage to fully automate on our current setup, then we can actually use AI to figure out how to actually do this this middle part much more efficient, and that's where things really change. So either the massive performance boost will happen there, or it happens in the quantum space. It's very hard to know right now exactly where it will.
Super exciting week. We'll do this again. So tune in, everybody, next week.
Yes.
And we'll be constantly adding our thoughts to the week's most exciting events. Thank you very much.